Hi everyone, I am Kotesh, your senior. I am here to discuss about nuclear power plant. The power plant in which electrical energy is generated by converting nuclear energy into electrical energy is called nuclear power plant. Nuclear energy we can generate by the nuclear reaction. Nuclear reaction, it is of two types: nuclear fission and nuclear fusion. So in nuclear power plant we use nuclear fission to generate the nuclear energy. So let me explain you what is nuclear fission. So when the neutrons are bombarded with heavy atoms, like heavy elements like uranium 235 or thorium 232. So when the neutron is bombarded with heavy elements or heavy atoms, uranium 235 or thorium 232, the atoms split, the uranium atom split into two equal uranium atoms and generates the huge amount of heat energy. As well it generates three more neutrons. These neutrons we call as fissile neutrons. Again further these neutrons again goes and bombard with this uranium atom. Again it keeps on splitting. This process keeps on repeating. So much of heat energy is generated. So by using this heat energy we are going to generate the electrical energy. So now let's see how we are going to generate the electrical energy by using this nuclear energy. So you can observe here the schematic diagram of the nuclear power plant. See, first we have here a nuclear reactor. First let me show you how the nuclear reactor is going to be there. So first mainly the nuclear reactor consists of fuel that we are using here, uranium fuel, and this is moderator. These are made of graphite, and these are control rods. This is a cylindrical vessel, placed in cylindrical vessel. This is a pressure vessel in which the nuclear reaction is going to be happen. This is a heat exchanger. Okay, so what happens? So when the neutrons goes and bombard with this uranium atom, when this neutrons goes and bombard with the uranium atom, to a few more two more uranium atoms generate, and some heat, a huge amount of heat and energy generates. As well also a few more neutrons also will, three more neutrons will generate, right? So in this way the fissile neutrons will be generated. Again this neutrons goes and bombard with this atom, again heat generates. This process continues and so much of heat energy is generated. So the heat is transferred from nuclear reactor to the heat exchanger through the coolant. It is made of sodium metal. So through the coolant the heat generated in the nuclear reactor is transferred to the heat exchanger. In the heat exchanger there is a water present in this. So we know that water absorbs the heat, and when the water absorbs the heat, the water converts into steam, right? So the heat that is present in the coolant is being absorbed by the water. So again some amount of heat is present in this, right? Again it is fed back to the nuclear reactor. So this process continues and the water gets keep on heating and converts into steam. So if you observe here, so we know that the nuclear reaction, it's a continuous process, and if we don't have a control over it, it's keep on repeating, and there's a chance of explosion. So we need to have control over here. So we have here moderator rods. It's made of graphite. What the graphite rods does is, it slows down the speed of the neutrons such that the reaction gets slower, and we can control the reaction. And if you want to control, or if there is no requirement of the load, or if there is no requirement of generation of electrical energy, if there is no load, if you want to stop this nuclear reaction, here we have control rods. They are made of cadmium. The cadmium it attracts the neutrons. So when we have to stop or regulate this reaction, we have to push the control rods inside, deep inside, such that the neutrons that are present in this get attracted to these rods, control rods, and such that the reaction gets stopped. So this is how the reaction gets stopped, right? Okay, so now I think you got an idea about the nuclear reactor. So the heat energy that is generated in this nuclear reactor, it is transferred. This is coolant. Just now, as I said, this is a coolant. So it is transferred to the heat exchanger through a coolant, and we have water here, and the water gets converted into steam. Now the steam is the steam is traveled to the traveled through the valve to the turbine. Here the turbine, it's like this. It has blade bucket like shape. We call it as turbine blades. So this steam goes and hits this turbine blades, and this turbine starts rotating. So we are converting the steam energy into turbine, or it's rotating. That means mechanical energy. So if you observe here, the turbine and this alternator is nothing but the AC generator. We call it as alternator. It requires excitation. So we have here exciter. So if you observe here, the turbine and the alternator are coupled to each other. So what is generator which converts mechanical energy into electrical energy, right? So we have coupling here. So when this turbine starts rotating, as there is as the alternator shaft and turbine shaft are coupled, so the generator shaft also start rotating, and it start generating the electrical energy. So the electrical energy is generated in the generator. So we have here step up transformer. The reason behind of using this step up transformer is to transmit the power to longer distances. We have I square, or means conductor losses will be more. So if we generate it, if we send it by voltage, the losses can be somewhat decreased. So what we should step up the voltage that is generated over here, and we have isolator, circuit breakers, and isolator for the protection purpose. Again we give it to the bus, and from bus the transmission distribution happens. So I think now you got idea about all the flow of the steam, right? So when the steam hits the turbine blades, and somewhat steam all the energy that is present in the steam don't may not be utilized here. Somewhat steam is present, and as an engineer we should not waste it. So we call it as exhaust steam. The steam energy that is still present in the after heating the turbine blades comes down and goes into the condenser. The condenser, condensation, right? Condensation means conversion of vapor or steam into liquid form. It is called condenser. It is called condensation. So condensation happens in the condenser. It travels through the cooling tower. Cooling tower it's very long. So when we cool this the steam converts into water. Again it keeps circulating, and in the process it turns into water. If we require if we have the requirement of more water, we can also take from the river. And here if you observe here, so the water is fed from here. This is feed water pump. We can take from even river also, and the steam and the water that is come out of the steam. So both are feed water. So this water only we have heated and again converted into steam. So this process keeps continuing.